So most of you probably haven't seen much of any Haskell before because it's not really the kind of thing that's covered at pre-university level very much. So what I'd like to do is to give you a quick demo of a Haskell program we'll be looking at in more detail later on in the course, and then I'll show you the program and we'll see a kind of flavor of what Haskell actually looks like when you write a more sophisticated program like this one. So here's the program that we're going to be looking at. It's a countdown numbers game solver, and as I'm sure many of you know, Countdown is a program on Channel 4 in the UK, and it was actually the first ever program to be broadcast on the channel. And Countdown is a game show, and it includes a number of different games, one of which is a numbers game. And the idea in the numbers game is you're given a bunch of numbers, and you're given a target number, and you've got to combine those numbers according to certain rules in order to try and reach precisely the given target. So let's have a little example of this thing running in practice, and then we'll have a look at the code. So if I run the program, and it's waiting for me to give it some given numbers, so I have 1, 2, 3, 4, 5. Let's give some simple numbers to start with. And let's have a simple target. Let's have the number 100. And what the program has to do then is to try and combine some of those given numbers using just the normal arithmetic operators, and it's got to try and build an expression which evaluates to precisely 100. And it turns out you can do that very simply. In fact, it's found one solution in 1/1000th of a second. And you can check it's actually found a solution. 2 plus 3 is 5, 4 times 5 is 20. And then when you multiply the two parts, the 5 times the 20, you get 100. And the program will actually, when you press return, it will find all possible solutions. And for this example, there are 8 solutions, and it managed to find them very quickly in just under 5/100ths of a second. So let's maybe try another example. Let's try a more sophisticated example this time. Let's say 1, 3, 5, 10, 25, and 50. So some slightly bigger numbers, and let's try a slightly bigger target number as well. Let's try 999. There's what we get. So it's found one solution in about 7/100ths of a second, and when we press return, it finds all 77 solutions in about 1.5 seconds. So that's what the program does. Let's have a little look at what it actually looks like. So here is the code. So what we see at the top is something which is very familiar from any programming language. We're just making some imports. So we're using some libraries. So in this case, I'm using an input-output library. I'm using a timing library because it was telling me how long it took to find solutions. And the program's got a lot to do with numbers, so I'm importing a numeric library as well. So this looks all pretty standard. It's the same kind of thing as you'd find in any old programming language. But then when we move a bit down, things start to look a bit different. So what we're doing here is we're defining a bunch of stuff to do with arithmetic operators. And first of all, what we're doing is defining a data type for the 4 arithmetic operators. So here's the Haskell syntax for declaring a new data type. We're saying that an operator here can either be an addition, a subtraction, or a multiplication, or a division. Very straightforward. Then I'm defining a bunch of utility functions on the operators. So here, for example, I'm explaining how to print or show an operator. So for example, you just show an addition operator as a plus string. Very, very simple. If I go down to the bottom here, here is a simple application function for operators. So what it's doing is it's taking an operator as an input, and then 2 integers as an input, and then it's applying the operator to these integers to give a result. And again, the definition is very straightforward. Here we're just applying an addition operator to 2 numbers, x and y, and we get back x plus y. And you might be thinking at this point, this kind of stuff looks very much like mathematics, and that's no coincidence because Haskell is a functional programming language, so when you write your programs, you're just defining normal mathematical functions. And the syntax, as we see here, is very, very similar to normal mathematics. So let's scroll on a little bit and look at some more stuff as well. So here is a bunch of stuff to do with numeric expressions, so we'll talk through a little bit of this. So here is a data type for representing expressions. So this is things like 2 plus 3 times 4 and so on. And what's interesting here is this is an example of what we'll see to be a recursive data type. So it's a data type defined in terms of itself. So what I'm doing here is I'm saying that an expression can either be an integer value, like 5, or it could be the application of an operator, like add to two sub-expressions. So again, this is an example of what we'll see to be a recursive data type, because I'm defining the expression data type in terms of itself. And then we have a bunch of utility functions on expressions. Here we're explaining how to print an expression, and here I've tried to actually minimize the brackets a bit, so that's why the definition is a bit longer than the previous one for showing an operator. Then we have two utility functions on expressions. This one takes an expression as input and it pulls all of the integer values out of it. And again, this is interesting. It's a recursive function, and recursion is going to be one of the main things that we're going to be thinking about in the course. Here we're defining the values function in terms of itself. So it's what's called a recursive function. And then down the bottom here, we have another little helper or utility function, which is going to evaluate an expression. And an interesting thing here is some of you may have seen things that look like this before. This is an example of what's called a list comprehension. And list comprehensions are a simple way of programming with lists in a language like Haskell. And actually many other languages these days have them too, for example, Python. So that's all I really wanted to show you today about Haskell. I'll just give you a flavor of what it looks like. Some bits look very similar to other programming languages, like all the imports, but quickly things start to look very different and actually start to look very much more like mathematics. And we'll see this illustrated much more as the course goes on. So again, this is an example we're going to come back to towards the end of the course, because it brings together many of the ideas which I'm going to teach you about programming in Haskell. But if in the meantime you would like to have a look at this program, I've put it on the web page and on the Moodle page for the module as well, so you can have a look at that if you wish. So that's all for me today, and I will see you again next time when we do our first proper Haskell lecture.